In this video I wanna show you how you can build a simple link shortener service. Like any other service, this one consists of two main components, an HTTP server and a database. For this video we will use SQLite as our database. Let's jump straight into the code. First we need to set up the database. It will have only one table with 3 columns: the original link, a hash of the original link, and a unique ID for each entry. And please don't forget to check everything for errors. The HTTP server will have 2 endpoints. The first one generates short links and saves them to the database. Let's implement it. The endpoint handler accepts a JSON object with the original link. First we check that the HTTP request contains a valid object. If something is wrong, immediately return an error. After that we will execute a couple of database operations. The first one saves the original link to the database. It's simple. Once the link is saved, we get the unique ID that has been kindly generated for us by SQLite. And next go the most interesting part, generating the hash. Let's take the original link and add the ID to the end of it. And then let's use the string as an input for the SHA-256 hash function. This function generates quite long strings, and we don't want to end up with short links being bigger than the original ones. So we simply take the first 10 symbols of the result. And this is our hash. Now we need to store it in the database as well. You might wonder why I do this in 2 steps. Why not just generate the hash directly from the original link and save it in one operation? I do it this way because I want the service to always generate new hash, even if a user creates short links for the same URL multiple times in a row. Maybe you don't need this behavior for your project, but I think it's important for a good user experience. By the way, as you can see, I'm using the mechanism of transactions here. This approach allows me to safely perform multiple operations with the database without breaking its state. For example, if the second operation fails, we will get a database record where only the original link is saved, but the hash is missing. This can cause some strange errors later on, but transactions help us to avoid situations like this by rolling everything back if something goes wrong. Okay, I think it's enough databases. Let's finish the handler. The last thing we need to do is to generate the short link, and that's just the server address plus the hash. The second handler is much simpler. Its path is dynamic and looks like this, or even this. The second part is basically a random hash we generate in the first handler. When we paste this string into a browser, the browser sends a GET request directly to our second handler. All we need to do is to extract the hash from this request and try to find it in the database. If there is no match, we return the error saying that no original link was found for this hash. If we do find a match, we return an HTTP redirect response and the browser takes care of the rest. The implementation is now complete, so let's test it. First we will create a short link using the first endpoint. Open the command line and type curl. This is the tool for sending HTTP request. Header will contain content type JSON. The HTTP method will be post, and the body will contain a JSON object with the original link. At the end, type the path to the first endpoint and press enter. And just like that, we get the shortened link. Let's send the request a few more times to make sure we get a new link each time. And as you can see, it works as expected. Now, to test the second handler, let's open the link in the browser. And here we are. The browser redirected us to the original link I saved a minute ago. What if we paste a link that does not exist in the database? We get an error. This is also very expected. One last thing I wanted to mention about this implementation. It's a good idea to create an index over the hash column to make the search faster in the second endpoint. Oh, and I just realized I forgot to add protection against SQL injections, so you'll have to do it on your own. If you enjoyed this video, please like and subscribe. Thank you for watching.